Okay, now we're going to talk about radian measures. And we're going to draw angles the exact same way we drew angles in the last video. And everything about this video is going to be the same as the last video. There's only one little difference. And we will be working in radians instead of in degrees. So the purpose of this video is to help get you used to radians, the process for drawing and stating coterminals and reference angles, all that stuff is the same. So the only difference is a full circle in radian measure is 2 pi. So that means coterminal angles will be adding and subtracting 2 pi to get that exact same terminal ray. You just have to add or subtract 2 pi. So how can we do this? Because I know you guys are not exactly huge fans of fractions. So think about this. A full rotation of a circle, just think about it in terms of 2. For now, just think about it as terms of 2. And if you have 4 quadrants, if you divide by 4, 2 divided by 4 is 1/2 or 0.5. This is 1 pi. This is 1.5 pi. And then there's your 2. So when you are graphing these, if it's easier for you, you can think about it in terms of decimals. So if you know that every quadrant is 0.5 away, and you're going to graph pi over 4, think about it in terms of 1/4, which is 0.25. 0.25 would just be going halfway to 0.5. And that's it. You're done. You just graphed pi over 4. It's not difficult. It's just different. So -5 pi over 2. My goodness, what are we going to do? Well, think about it in terms of -2.5. So you're going to go negatives. There's -0.5. There's 1. There's 1.5. There's 2. There's 2.5. Every time you hit an axis, that's 0.5 away. So there you go. You just graphed -5 pi over 2. That's it. Nothing else to it. So if it helps you to think about it in terms of decimals, you go right ahead. Now there's another way to do it, but I encourage you not to. It's just change it to the degree measure and figure out what degree it is and then graph in degrees, because let's all face it, you're used to degrees. But you're going to be doing radians for a while. You're going to be doing radians once you get to pre-calculus. It's going to be a helpful thing to know how to do. So just practice getting good at working with radians. So think about it. 11 pi over 12. Now let's think about it in terms of fractions. 12 pi over 12 would be 1 pi. So 11 pi over 12 would be like splitting just 1 pi. So we imagine that we have just this whole top, and you split it into 11 pieces. So that means you're splitting it up 11 times, or 12 times for the whole top. So then you just have to do 11 of them. Now let's think about that then. If you're going to go 11 out of 12, then you're going to end up really close to right there. And that's it. You're done. Like I said, I'm not looking for perfection. I'm looking to see if you have an idea of where it's going. But if you really had to, you're at 0.916, so almost 1. So there you go. Now this will be a little refresher from yesterday. You have 3 pi over 4, which is approximately 0.75. So you're going past 0.5 halfway to 1. And now we have -5 pi over 4. So that's -1.25. So here's your -1, and there's your 0.25. They are again called coterminal angles, meaning they share the same terminal ray, even though we got there in a different way. Okay? So that's radians for you. So going on to coterminal angles, the only thing you have to do is add and subtract 2 pi until you get a positive or a negative, whichever we're looking for. So if you add 2 pi to a -3 pi over 5, all you have to do is type it in your calculator and change it back to a fraction, and you'll get 7 pi over 5. To get a negative, all you do is subtract 2. So you would subtract 2 from negative 3.5 and you would get negative 13 pi over 5. Calculator will do it for you. Should you be able to do it in your head? Yeah, pretty close. But don't worry about it. That's what our calculators are for. 14 pi over 3. Add 2 pi. Change it to a fraction. You get 20 pi over 3. 14 pi over 3 and subtract 2. And you're probably not going to be there yet. So you're going to have to subtract 2 again. And you just keep on subtracting 2 until you get to a negative decimal in your calculator. And then you just change it to a fraction. And that should be negative 4 pi over 3. Of course, you can have infinite answers with these. You can keep on adding 2 pi. You can keep on subtracting 2 pi. As long as you have one positive and one negative coterminal angle, you're good to go. Reference angles. Again, same rules. Always positive. Always from the x-axis. Always going to be less than pi over 2. We're in radians. It's not 90 degrees anymore. So, how are we going to do this? 3 pi over 5. Well, the first thing you should do again is graph it. So if we graph 3 pi over 5, which we can say is 0.6, that's a little bit past. Now, you just went 3 pi over 5. Now, you have to think that you're closest to pi right now. So you would just do pi minus 3 pi over 5. But in the calculator, you would just do 1 minus 3/5. You do not type the pi symbol in your calculator and expect it to give you the fraction. And then you would just change it back to a fraction, and your reference angle would be 2 pi over 5. Now, think about that. 3 pi over 5. Pi would be like saying 5 pi over 5. So we went 3. How many more do we need to go? We need to go 2 pi over 5 more to get to 5 pi over 5. That's how you think about it. Negative 3 pi over 2. So here you go. 1, 2, 3 pi's over 2. And that is exactly 1 quadrant away. And in radians, a quadrant is pi over 2. Because you need to be at the x-axis, not the y-axis. Last one, 13 pi over 8. So you're going more than 1, and you're going to keep on going, and here's where you are. Now, if you needed to do that with a calculator, that's fine, but 13 pi over 8 is close to 2 pi. So 2 pi would be like saying 16 pi's over 8. And you just went 13 out of those 16. So how many more do you need to go? 3 more out of 8. All right? That's reference angles. Same type of situation. It's the exact same thing. Only difference is you're in radians. So now we're going to convert again, but now we're going to take our radian measure and convert it to degrees. So this is the opposite of what we did in the last video. We take our radian measure and we multiply it by 180 and we divide it by pi. So basically what we're doing is we're just canceling the pi's. We have 180 divided by 6, which is 30 degrees. That's all you're doing. So for this next one, you're multiplying by the 180 and dividing by the pi, which means you're just canceling the pi's. Negative 17 times 180, and then we're going to divide by 3, and you'll get negative 1020 degrees. So again, basically what you're doing, the shortcut way in your calculator is eliminate the pi and just type 13 divided by 11 and multiply it by 180, and you will end up with 212.73 degrees. That's it. That's all you need to do. All right, so now we've worked with everything in degrees and in radians. So there's one more problem again. See if you can do the exact same thing. I want you to graph negative 11 pi over 6. State a positive coterminal, state a negative coterminal, state the reference angle, and state the degree equivalence. Pause the video, try it on your own. If you get it all, you're good to go. Here you go. Coterminal angle, pi over 6 and negative 23. Pi over 6 are your positive and negative. Yes, you can have a different one. As long as it's correct, you're good to go. The reference angle, think about this. Negative 11 pi over 6 is pretty close to negative 2 pi, which is negative 12 pi over 6. You went 11 out of the 12, so you're missing 1 pi over 6. And all you have to do is negative 11 divided by 6, multiply it by 180, and you will get negative 330 degrees. And that's it for radians. This is Longo, and I'm out. See you, bye.